Okay, hopefully you guys can see my screen. And of course I already hit go forward. Welcome everybody to the November edition of the Women in Tech virtual group. We meet every month, typically on a Wednesday, where we host women speakers on a variety of topics, either in the data platform or something specific to do with women in tech. Our user group, An Embarrassment of Riches, we have two sponsors, SentryOne and Redgate. So at the end of the session, I will give away 2 gift cards. And they will either be Visa or Amazon. There's a transition going on. I'm not sure where we are in the process of what it is that you'll get, but they are from the generosity of these 2 companies. We're really glad to have them. PassWit is on YouTube. You don't have to memorize that link or copy that link. You can just go to YouTube and do a search for PassWit. All of the sessions that we present every month are uploaded. I should have this one uploaded by the end of the day. If I haven't, feel free to send us an email or a tweet asking me to get off my bum and get it loaded. Join our virtual chapter through pass.org. And you can also get our monthly newsletter where we highlight a woman blogger in the data platform, provide some links to interesting articles and things like that. You can follow us on Twitter at @pass_wit or use the hashtag #passwit whenever you find something that you think would be interesting to the other members that are here. We only have a couple of SQL Saturdays coming up in December. I think with the holidays, people try to avoid it. But it's Slovenia and DC. This is actually the first year in 4 years that I'm not going to DC, so I will miss my friends there. Upcoming sessions in February, we have Winning the Head Game in 2019, Bobby Jo Brighton. She actually presented for us a couple of months ago, I think in August. She's kind of a life coach kind of woman, and I think a lot of people have some really positive things to say about what it is that she's presenting, so we've asked her to come back. Next week, actually, will be the December session. Shabnam Watson, Performance Monitoring Analysis Services Tabular, will be her session. She did that for the Atlanta user group here last month. And of course, today's session is Ginger Grant using Azure Databricks, a scalable data solution. She presented this session at Past Summit, so you guys are saving a couple $1,000. Although you're only getting 1 session for it. Sorry about that. But let me turn this over to Ginger, if you're ready.
Yes, thank you so much. Let me just...
Okay, by the way, I will mute my microphone, but I'll unmute if I have any reason for anything. And then let me know if you have any concerns.
All right. Assuming everyone can see my screen now.
I can. Yes, lovely green.
Wonderful. Yes. All right. Well, today I'm going to be talking about Azure Databricks. Azure Databricks is a new third-party entry into Azure, and it's gotten a lot of conversation around it. It is looking to be an additional way of doing things that are already in Azure, but using Spark and an open source version, and so it's gotten a lot of buzz in the industry. So I know a lot of people are really interested in finding out more about what you can do with it and what it's good for. So a little bit about me. My name is Ginger Grant. I am on Twitter way too much at Desert Isle SQL. I do a bit of writing. I've got a blog at Desert Isle SQL, and this year I was part of the team that wrote the Azure Machine Learning 7774 exam preparation book, so I've written that one too. I am a data platform MVP and a Microsoft certified trainer, and I speak a lot. And if you have any questions, feel free to either drop me a line or on my email or send me something on Twitter. So a little bit about Databricks. What is it? Today we're going to be talking about, what you can do with it. It's a different environment for developing and running jobs. You can write different languages using Databricks. It's open source. It allows for a team collaborative environment, so it brings a lot of the open source capability, but yet delivers it in a way that you can share it with others. It does integrate with other Azure services so that you can have data in a blob store and run it in Databricks. It's very scalable. It does its own job scheduling, and it uses Azure Active Directory for its security. It also is very scalable. One of the really neat things about Databricks is that it will use the resources that it needs to do the job. So if you need running a really big job and you need to have a ton of cores, it'll scale up and then it will scale down. It's got some neat features for decreasing the amount of Azure spend that you have as well. You can run its jobs by itself, or you can integrate it with Azure Data Factory. So a little bit about the history of Databricks. It grew out of Apache Spark. The people who wrote Databricks started by writing Apache Spark, and they wrote Apache Spark to help them win a contest that Netflix held a number of years ago for developing a machine learning algorithm to better predict movies. They didn't win the competition, but they did create a new environment for doing data analysis. A couple of years ago, they decided that they wanted to be able to improve on the Apache Spark development project that they did, but they wanted to create a company to do that. So the people who met at Berkeley decided to create Apache, to take the code that's from Apache Spark and move it to Databricks, and use the same in-processing memory framework and add some items to it, and use the cloud. So this is a cloud-based application only. It was originally released in at the Amazon cloud earlier this year, and then in April 2018, excuse me, it was added to Azure in March of this year to further expand the places that you can use Databricks. Now, what I'm going to be talking about is specifically to Azure, but I would say that 90% of what I'm talking about would work the same way if you chose to run Databricks in the Amazon cloud, should you choose to do that as well. So what is Spark? Spark is part of the Apache Collective. So it is designed to work with big data using the HDFS file system. And this is important because that means that for the technology to work, the data needs to exist within Databricks in the HDFS format. How then it processes the data is it breaks up tasks into parallel processes, reads and writes some data, and caches it into memory very efficiently. So it's designed to process data very iteratively very well. So it, running the same thing multiple times through a large set of data is what it's really good at, which makes it ideal for doing machine learning. What this means, though, is that all of the data that you are going to be using for your analysis needs to be imported into the Apache, into the Databricks framework so that it can do this kind of analysis on the data. So you're not ever going to directly connect to anything like SQL Server, because part of the way that it works is by using HDFS. So it is really ideally designed for machine learning. Oftentimes machine learning jobs are very intense in terms of the compute power that they use. It may be for a short period of time, it may be for a long period of time, and after that the resources aren't needed at all. One of the things that with machine learning does is it iteratively runs algorithms on data, which is uniquely designed to be what Databricks is very good at. As a matter of fact, there's a really good demo that Microsoft has done recently on determining whether or not pictures that are being taken of cameras in remote mountains have snow leopards in them. As you can imagine, processing visual images to determine content is a huge undertaking, and they used Databricks in part to do that kind of analysis because it allowed them the ability to use a nearly infinite number of resources, when they had the pictures to process, and then the whole thing gets shut off. The languages commonly used to write Databricks codes are R or Python. You can also use Scala. So what you choose to write it in is up to you. Processes are either run as batch or streaming, so whichever way you want to send data to Databricks, it will work just fine. So you can use either method. So what Databricks is really good for is designed to create analytic solutions. What you can use to create these solutions, of course, you can use SQL. Now, because like I said earlier, how Databricks works is it is loading its data into an HDFS format. It's not using SQL as you know it. It's using a form of SQL commonly known as SQLite, a lightweight version of SQL that will do standard operations, but don't try doing anything complicated like a CTE because it's more generic SQL than that. It also includes out-of-the-box data visualizations. A lot of time when you're writing code in languages like R and Python, you create a lot of visualizations to kind of speed up the analysis of the data. You can do these with point-and-click operations within Databricks. And like I said, it has multi-language support. One of the things about these modern languages, they do require the use of lots of different libraries. So you can use whatever libraries that you wish to include within your code. You can simply load them up into the environment. You're not dependent on a set number of libraries that are maintained or supported by Microsoft just because you're in the Azure cloud. That it uses data storage. What data storage is pretty much up to you. Generally speaking, when you are loading data into Databricks, you may be loading it from a blob storage of some kind, and you can also write to blob storage. So it will write data in and out so that you can parse it and then get the results. So it is considered a managed service offering. We'll take a look at it, of course, here as part of this presentation. But what you get with Databricks is you get a totally separate environment outside of Azure. And to do this, it integrates your Azure Active Directory security as part of Databricks. Now, this is kind of important because Databricks was designed to create code in a cloud environment that you can share with other people. So you could create an Azure Active Directory group and share everything in the environment within the people in that group. It also has direct interface of your code to GitHub so that you can have source control in your code natively. I know this is kind of a thing that a lot of the cloud-based stuff do not integrate, but Azure Databricks does include GitHub integration so that you can version the code that you are running. It is a serverless runtime. Again, you can use whatever resources that you would like to have. It uses Apache Spark and Apache Spark ML in terms of to run, and it uses its own proprietary Databricks, interface to talk to the files. So accessing data to Databricks, how do you run one of these things? Well, you can integrate it with Azure Data Factory. If you wish to, you can have that be a job. You can move data that's stored in Azure into its environment so that it can internally run it into HDFS. There is no way that you can integrate it with anything that is not in the Azure cloud. This is a cloud-based secure environment that has no access to your on-premises data. If you need to use on-premises data, you would probably need to download a data gateway, upload your data into Blob Storage, and then you could access it directly from within Databricks. But there is no way of connecting Databricks to anything that's not in Azure. That's just not possible. And the reason why is because of the security involved, because when you do that, you are punching a hole into the Azure cloud, and you want to make sure that everything that it's done is secure. So that's not something that you can do directly, but indirectly you can get your data there. So all the code is written using Jupyter Notebooks. I did a webinar a little while ago on Jupyter Notebooks, so if you want to get up to speed at that, look in YouTube up look me up under Jupyter Notebooks and you'll find the presentation that I did there. It started out as IPython notebooks. It's an integrated code and data environment that is very common for R and Python. It includes both of your code and then the data, so you can see what the data is done. You can widely use in many existing environments, and you can use Markdown to format the text. If you're not familiar with Markdown, it's definitely something that you need to get yourself familiar with, because there's so many things that are using Markdown. So when you have a Jupyter notebook, not only does it exist up in the cloud, but you could also download that notebook to pass it to somebody who perhaps isn't in your tenant and wants to actually just look at the code. So this collaborative environment integrates well with the standard corporate environment, because after all, most people want projects accessed by teams of people. They're not looking for a one-person solution. Multiple people need access to the same files, and those are some of the things that are provided for within Databricks. It has integrated source control, and it's got a fully managed environment so that you can include groups of people to be able to access certain workspaces. So that is controlled through Databricks, and then of course the people do need to be included on your Azure tenant. So it's a fully interactive team environment. So one of the things that's really super cool about the way that Databricks works is that it is designed to economically use Azure resources. By default, it's going to turn itself off in 2 hours. Speaking for myself, if anybody has accidentally left a Hadoop cluster running over a couple of days, you'll really appreciate the fact that it is smart enough to turn itself down. Of course, that's a default. You can change it. But it's designed to also auto-scale based on the load. So you can determine the number of clusters that you want to devote to it and go anywhere between, I think it's 128 different cores if you want to be able to scale it up that way, or you can just stick with 2. It had the processing capabilities, of course, fully up to you. There's a whole bunch of different pricing details. I don't really want to get into it here. I've got a link to the pricing details that Microsoft provides. The pricing is, of course, higher the more cores that you have. If you have faster disks, of course, then it's also more expensive as well. So there are 2 different tiers, 2 major tiers, standard and premium. And if you want to have if you get the standard version, standard does not include all of the team functions. So if you're kind of not really doing a whole lot with team functions, you just want to add a couple of people to the workspace, and that's more of what standard is. Premium, of course, includes all of the features. If you want to go ahead and try this out, there is a trial that is available for 14 days, so you can give it a try without having to incur charges within it, and you can convert this directly to a pricing tier should you wish to do so. There's 2 different workload options, data engineering and analytics, and the big difference on those is within the standard tier, data engineering doesn't include interactive clustering. So if you want interactive clustering, you're going to want to go with the workload option of data analytics. So a little bit about the process that's needed to create a Databricks process. First, what you are going to do is you are going to create a cluster, and then you are going to load a reference data source, and we're going to walk through these steps, but I just wanted to tell you about it before I showed it to you. And then you're going to put your code in a notebook, maybe create a dashboard, look at the data sets, implement a runtime solution, and schedule the ongoing running of the job if you want to run it more and more often. So if you're doing and implementing a machine learning solution, what you can do is write some R Python code, rewrite it, rewrite the code in Java, write a web service or API to implement, migrate the code to SQL Server or web server, or you can just do everything within Databricks. So once you've got that R Python coded, Databricks will allow you to create a deployment solution that you probably are not have done in the past. So let's take a look at actually Databricks. So if you want to create a new Databricks resource, which I'm going to go ahead and do, it is relatively simple to do. However, this does take 20 minutes, so I'm going to use what I call the Julia Child version of this. I'll show you exactly what you need to do and then go into one that's already running, because I don't want to tap dance for 20 minutes while this gets configured. So I've gone to within Azure. I can go ahead and select New, and then Analytics, and then go to Azure Databricks. And within Databricks, I can just type a workspace name, pick my subscription. I'm going to go ahead and create a new resource group, because naturally you have to have one for this. Picking the location. Oh, by the way, this does matter because different locations have different pricing groups. For example, if I select West US, I will have some of my options will be different, but so you want to take a look at that. I've got standard, premium, and trial. So if I went ahead and create, then this would automatically then go through and create it. But like I said, this takes 20 minutes. So I could just go ahead and click create if I selected premium. But I'm just going to go ahead and show you one that I've already got created. So I've got two different workspaces. What you see in Azure is you see that you've got a workspace button here. Pretty much everything else is not important. So what I can do here is I can go ahead and I can launch my workspace. And when I do, what it's going to do is it's going to take my Azure Active Directory account information, and since I have lots of accounts, that's why it prompted me with that. And then it's signing into Databricks, because Databricks is its own completely different environment. So if I'm within my environment now, and this is where I land, and this is the home section, which shows you the different workspaces. These are the recent files that I've taken a look at. Here is the data sets that I have loaded, and then clusters. Now, all of your data needs to be loaded to a cluster, because a cluster is what the HDFS file system is running. So the first thing that you need to do when you are creating a Databricks environment is create a cluster. So I'm going to go ahead and show you how to do that. So I'm going to go ahead and pick a name. High concurrency is run to known as concurrent information. So if you do a lot of things that's streaming, it does not support Scala. So if you're interested in that, keep that in mind. I generally do not run concurrent jobs, so I go with standard, which is a little bit less expensive. For Databricks, the runtime is defaulted to the latest version. You could include the beta versions if you are that adventurous, but it'll default to the latest version of, but it doesn't, unfortunately, send itself to the latest version of Python. Python 2 has been deprecated. It's not been actively worked on since 2008. So you want to make sure that you remember when you see this, if you're doing Python, to make sure that you pick Python 3. Now, there are two, if you are at all familiar with HDFS, you'll know that you've got driver and worker types. So this is where my cores come into play. and the options that I have available to me in terms of compute options. Remember when I was saying before that the different options matter depending on where you pick? Different one of these drivers are dependent upon where you selected the item to be. So keep that in mind when you're doing it. There is a cost involved with the number of jobs and cores. I'm going to go ahead and pick standard here. This is the same. And this is my minimum and maximum number of workers. So this has high of scaling as I am allowing myself to go. Notice that auto scaling is enabled. So when I need more resources, it's automatically going to scale them for me. And it is going to automatically terminate after 120 minutes. Obviously, I can change this to whatever number that I want, or I can not click this and then it'll just keep on running all the time. But generally speaking, you're going to want to, put that on there and have it terminate. And then it is going to, if you have any specific configurations, generally speaking, that's not required, or initial scripts, you can load those as well that you might need. But if I go ahead and say create cluster, in about 15 minutes, I will have a cluster available for me. So since I'm lazy, we'll just take a look at the cluster that I have already created. So if we go here to my cluster, we can see that I've configured it pretty much the way that I was telling you previously. Python 3 standard with 2 workers and 8 max, and it will terminate after 120 minutes of activity. Notice that once you've got this selected, you can edit it. So I could, increase my capacity should I wish to do so. I'm going to go ahead and say cancel. You can also see the number of notebooks that are assigned to this, the number of libraries, the event log, and everything regarding what's loaded and running with this particular cluster. Although this is designed to auto terminate after 120 minutes, if I ever want to stop it, I'd say terminate. This will not delete or get rid of anything. It'll just stop it so that no resources are being expended. Of course, deleting it does exactly what you would think, but terminating it does not. So you still have all of your information there. So what we are going to do, since we've got a cluster created and we've got some notebooks already that exist, let's see. I'm going to show you a notebook here, and then we will take a look at creating a new one. So this is a very simple Jupyter notebook. This Jupyter notebook is loading data that has been previously uploaded to my HDFS environment. It is the Diamond data sets. And notice that it is allowing me to create a SQL table. So I'm using this magic command of SQL. And then what I can then do is do a little select statement on it. Now here's one of the neat things that I can do with Databricks. I can show my results as a graph, or I can show my results as a grid. It's automatically built-in functionality. I've got a number of different options that I can do. Let's see if some of them don't work as well because of the way I have the data formatted. Histogram seems to work kind of fine. So these are some of the things that you can do with with some code. So let's walk through and actually figure out how to make this happen. So what I'm going to initially do is I want to add some data. So I'm going to go ahead and say add data, and then it's going to just tell me to go ahead and browse for my data. So I'm going to go ahead and say browse, and I'm going to pick up some information on airplane crashes. So let's take a look at that data real quick. So this is my airplane crashed CSV, and you can see that it's got some dates, locations, who was operating it, the type of plane, dead, aboard, and ground. One thing that's kind of important to know about your data is, for example, this data contains blanks. That's not unusual with data sets. Data sets oftentimes aren't perfect, but since it contains blanks, I can't say that this is a date. I will get an error if I define this as a date because a blank isn't a date. I can go ahead and look at my numeric fields here and notice that and I can eliminate the blanks here. And that way, I can go ahead and load all these as numbers. So I'm going to go ahead and do that. So I'm going to go ahead and say open. And this is going to upload my data. So my data is then uploaded. Now, I just uploaded my data from a CSV. Of course, I could also go to other data sources and get my information from Azure Blob Storage, the Data Lake store, JDBC, Cassandra, Kafka, Redis, and Elasticsearch. Notice Azure SQL DB is not here. I can't natively get data from there, but I can get data from a blob store. So I could dump the data there and then be able to access it. But I'm going to, but I shouldn't have done that. Should have finished this first. Let me go ahead and grab this again. This doesn't take terribly long. All right, so I'm going to go ahead and create my table with the UI. It's going to ask me, okay, what cluster do you want to use? And I want to use the one cluster that I have. So I'm going to go ahead and say preview table. So when I do that, I have the ability to specify my attributes here. And I can do things like set the first row as header. And I'm going to set this as an integer. And this is going to be a string because it's got some NAs in it. So I'm going to define this as what my table is going to look like. And then I'm going to go ahead and say create table. And it does that and shows me my sample data. Notice it hardly took any time at all. So I've got my data loaded and I can use it. So I'm going to go ahead and use my data by creating a new Jupyter notebook. So what I'm going to do is I'm going to go to Databricks and I'm going to create a blank notebook. So I'm going to go ahead and do that. And I'm going to call this Wit Crash. And I am now in a completely empty Jupyter notebook. So what I'm going to do is I'm going to actually take a look at some of the code that I have loaded up by creating a data frame. And this is defaulting in Python. So I'm going to go ahead and run it by using run cell here. And this shows me, again, the data that we looked at in a data frame. And it's only going to be showing me the first 20 rows. Well, that's one way of looking at it. To create a new cell, I can just hit this plus button down here. And I can go ahead and take the little bit more detailed look at my data frame by taking a look at the schema here. And this is telling me that what my data types are. So I can see that everything is string besides dead and abort. So I can see my data set contains the dates, location, operators, plain types for all crashes to see how many people were dead and how many people are on board and whether or not it crashed on the ground. So then what I can do, though, is because I am using Jupyter Notebooks, I don't just have to use Python if I want to. I can use this magic command, and the magic command being %SQL, and then I can run a SQL statement. So I can do something like selecting all of my text where dead is greater than 50, so seeing how many people were big plane crashes, and I can go ahead and run that. And see here, then SQL, it formatted just a little bit prettier, and I can see the dates and the crashes that were created here. So I've got the ability to create some interesting things about that. I can also kind of change around the different formats of how data is displayed for the entire data set. Notice I just selected this. I didn't make a new data frame. So this is still all the data is available in here, not just the ones where it's greater than 50. But if I just wanted to select information from a specific column, I can by doing selecting just that column from the data frame. So one of the things that's really kind of cool about doing things in Python is you can use one of the more popular libraries, which is pandas. So pandas is already loaded. The library exists already, so all I need to do at this point is just to run it. And this is telling me that it's loading my data frame into a pandas data frame and shows me the output of that in the first 5 rows that are included. And I can do something kind of clever by doing some Python code to plot some of this data. And I'm using the Seaborn library, which is very commonly used in Python. Notice I have to import it to be able to use it. And if I do that, I can get a little prettier graph looking at the number of dead versus the number of people on board. So just some more kind of data analysis that I might be wanting to do. You know, I can do something like doing the counts. Oops, I actually need to run this. And looking at if, you know, that there's, you know, a total of 26. And if I group by the dead, doing something like this. So one of the things that's kind of interesting, so I've got all of this data and information that's sent here. So, you know, so 148 people dead happened 2 times. One of the things that I can do is I could show somebody the results of my analysis by going up here to File and saying Export. Oops. Export. And if I export this as an IPython notebook, what you will see is you will see all of the data that is available in this IPython notebook format. And so anybody who, as an editor who can read an IPython notebook, can go ahead and take a look at it. Believe it or not, if you're not familiar with it, there are a number of them. If you're not familiar with a IPython notebook, there's a free one that's available for you in Studio at AzureML.net, and there's also a Google free one. And if you want another free one that runs local, the Anaconda distribution also contains an IPython editor as well. So any way that you want to do that, you can go ahead and open up those files. So this is a kind of analysis that I can do within Databricks. So this isn't anything special. I'm writing R code, I'm writing Python code. Well, I'm only writing Python code, but you could write R code, you could write Scala code. So it is just an environment for running or writing that kind of code. Nothing particularly fancy with that. I'm also doing this so that I have an iterative environment. If I'm just doing this, but I know all the job works, perhaps I did all this analysis locally on a smaller data set, I could then just paste all of my code in here and run it, so it would run it in all one cell. So just a couple of the options that I have available. All right, so let's take a look at some of the other things that we can do with Databricks. So what you can do with Databricks is you can use it to create production-ready code. So once I've created that code, technically speaking, it's deployed. It's in the cloud. So that I go ahead and scale it to whatever I want to. The big things to remember are making sure that you've got the data added to Blob Storage so that it can be read into the HDFS cluster. You could use to get data to and from Azure databases. Just because it only talks to Blob Storage doesn't mean that you can't put something else. Rhea, do you have any questions at this point?
I did. Can you hear me okay?
Yeah.
Oh, good. Sorry. I had to pull out my headphones, put them back in, and pull them out, put them back in. Really quickly. So I have several, and maybe some can wait till the end, but one probably that fits the most recent thing you had. What's the difference between create table and create table in Notebook?
So when I'm creating a table in with data, what I'm doing is I am creating a table that I can load and use with a notebook versus doing it in a notebook. So this is an upload of the data. It's part of the data access within Databricks.
Okay. Let's see. We have once you load the data, is it persistent, or do you load the data each time you run the job?
You can make the data persistent, or if you wish, you could have it load every time the job is run. It's up to you.
Okay, and then this one's kind of a two-part question. So somebody referenced finding premium necessary if they wanted to leverage Azure AD security. And it says what are the security implications for going with standard versus premium?
Okay, so I wanted to clarify that. I'm really glad somebody asked that. You will get Azure Active Directory security with either standard or premium. What you get with premium is you get more workgroup functions. So there is more functions around managing workspaces with people. So you will get Azure Active Directories no matter what. So that's not a consideration. So don't think that you're not going to get Azure Active Directory, because that's included for all versions. So it's just some of the team organizing options are not available. It functionally works the same. Okay. Any other questions?
I'm gonna get confused here. And did I ask the difference between an inactive cluster and a job cluster?
No. So the difference between an inactive, or if your cluster is inactive, then nothing will run. If I choose to stop my cluster, I'm effectively stopping everything that is running. The job clusters, what these are showing is when and this is kind of jumping ahead a little bit, but I have created a job that runs every day. When you are creating a job, it's very efficient to create a cluster, run your job, and dump the cluster. So that's what these are. These are clusters that were created for specific job runs and then dropped. But if I want to interactively use a cluster because I want to run a job against it, that's what needs to be run for me to run interactively with it. So those are the two differences. And I'll talk more about jobs. So if you don't get it, that'll make more sense soon.
Okay, so go ahead. You're good.
All right. So about jobs. So what you can do is you can automate your processes with jobs. What does that mean? If you want to run a job all the time, you want it to access streaming data, you want to pull from a blob whenever the data is available, and you want to run it. If you want to run it every day at a specific time, then you can create a Databricks jobs to run it. You do not need to use any other Azure tool to run it. You can run Databricks independently of any other orchestrator that you might use, like ADF. So Databricks jobs are actually very similar to SQL jobs. They can run code inside your notebook on a schedule. You can use the existing cluster, or you can create new clusters. So if you choose to create new clusters, what happens is it creates a cluster automatically for you, runs the code, and then destroys the cluster. What it is doing there, it is copying the data into the cluster, copying the notebook into the cluster, running it, and destroying it. This is a lot more efficient than using your existing one because it is up. The time that it is up is dependent upon the job. So generally speaking, you're going to want to create job-specific clusters rather than use your existing cluster for running a job, just as a money saver thing. So with jobs, you can have multiple owners of a job. Jobs can be created and notify various people when the job completes, when the job goes long. All that kind of thing is something that you could create within a job. You can send notification emails based on specified status. You can set alerts for failures. You can configure how many times it's going to retry, and you can also determine your scaling options. Maybe your Friday jobs run bigger so that you want to scale to more resources on that day. These are some of the components that you have available to you within Databricks jobs, which is really quite similar to what you might see in SQL Server. So the other thing that you can do with a Databricks jobs is what's called structured streaming. And with structured streaming, you're continually processing data that is streamed to you on a regular basis. A big example of this is perhaps IoT data. It integrates with Kafka and does interactive status metrics so that you can, the data is actually created a temporary table, sort of. The data is processed and then the rows are appended to the unbound table. So this is the kind of the streaming that it tends to do, that you can process data as you receive. One of the other things that is really useful for using Databricks, a real good use case for it, is it natively supports some of the deep learning algorithms. So TensorFlow, Keras, CNTK, those jobs tend to take extremely large amounts of CPU processing power and time. Generally speaking, that's not something that you stream either, so it would be a large batch job. Those are kind of ideal for Databricks because it allows to spin up more resources when you're processing these kinds of complex calculations, but yet allows for those things to be terminated. You can also create a lot of neural network ML processes in Databricks. And again, because of the way that they have engineered the underlying file structure and processing, it performs really, really well when doing these kinds of tasks, more so than perhaps other tools that are available today. So what I wanted to do now is take a look at the jobs that are available so you can see how you might go about creating a job. So back to Databricks. So what we're going to do is we're going to actually take a look at the jobs. And I'm going to go ahead and create a job. Now what I can do when I create a job is what it's going to do is it's going to say, what am I running? I can select a notebook. I can configure Spark Submit. So if I select a notebook, what I can do is say, I don't know, just do this one. So it'll load any of my existing notebooks that I have, and I can go ahead and say, okay. I can go ahead and edit the schedule, and it'll show me how often it is running. So I could run this every day. And I could start this, this is on Pacific. I could start this at 10 Pacific and go ahead and say confirm, and it'll also show me the cron syntax if I want. And so it'll go ahead and run that. I've got some more advanced options where I can set alerts. Here's where I would send emails. I could configure these when start succeeds or encounters a failure. Concurrent runs, so I could run this job multiple times at the same time. What am I going to do on timeout? Should I terminate it? Should I wait? Retries. How many retries do I want to have? So how much time do I want to wait until I try again? At most, how many times? So I want to do this like 10 times and then give up, after, every 30 minutes and wait. These are some of the options that I can specify. Retry on timeouts or not. So what I can then do is then I can also change the parameters in which I'm running. So I could specify JSON parameters for this particular job that would allow me to run the job with different parameters that I might want to add here. So then I can go ahead and say run now. Now, what this will do is this is going to do a pending run. Now to go back to here, what I've got is all my jobs. Okay, so what I have is I've got a job that runs every day at 4:20. And it creates its own cluster, and then it tears it down. And this is how long these tend to take. Notice there is some variability in how long the job takes to run. So even though that my data isn't changing specifically, the times it runs may. I can look at my Spark historical interface, and it'll load this cluster up that was created for it, and so that it can take a look at the event timeline for this. So again, it's going to take a little bit of time to go through the cluster, so to reload the cluster. So, but this is what you can look at for all of your jobs and the history for it. So And I've got this scheduled to run every day, and it's telling me that it succeeded, and it'll refresh this automatically. So, and these runs correspond with the job clusters that are created. And you can see there's one here that is pending on the job that I set up, but I don't want to necessarily wait for 5 minutes for that one to load up. So this is how it would definitely work. I can also within, oops, wait a second. I want to do that. So I can go back to the Azure portal if I wanted to. That's not what I wanted to do. I want to go to something that I forgot to show you before. In here, I can look at my revision history. I can link this to GitHub, and you can see the different versions that I have available. So if somebody has screwed this up, you can see when. And you can also take a look at the scheduling from within here so that you can see when a particular job has been scheduled, any and all comments that were made. If I just selected the code, then I could comment on it. Again, this is really good for different people. And this is in addition, this kind of thing, it really makes it more of a team environment than just say writing Python and running it yourself would be. So just a little bit of extra information about that. Okay, so in summary, we take a look at how to do Databricks, looked at the flexibility, the kinds of things that you can do with it. Extensible, you can use it to run a number of different languages, work with teams, use scaling, and you can also schedule jobs and be notified when the job completes, when the job runs, and retry it as configured as you wish. So with that, I just wanted to leave a little bit of time. So are there any additional questions about this, Ree?
Okay, sorry, it took me a second to get unmuted. So I have a fantastically worded question. I'm going to read it verbatim. Something that seems to draw different opinions from people is the use of Databricks for data engineering tasks like traditional ETL and ELT. Some people say it's very strong for that purpose. Others say no, we shouldn't start hand coding our ETL operations again. What's your opinion on using it for traditional data engineering tasks? Footnote, ignore Azure Data Factory data flows for the purpose of this question.
So regarding ETL, this has come up. Personally, I've written a ton of SSIS, and I can crank out SSIS to do some simple conversions a heck of a lot faster than I can hand code a whole bunch of Python for it. I think it is easier to maintain an SSIS package than a bunch of Python code, because Python code can tend to be all over the map, and that's what you're using to do your ETL. So I do think that you have to have a pretty good understanding of the language, and I think over time maintenance, if you're just using it for ETL, I think there are better tools for the job. Now, that without saying, there are some things that I would definitely use it for that aren't possible to use SSIS for. And that would be machine learning and large processing tasks. So there's a reason that Python has never overtaken SSIS as an ETL tool, because you could do that right now, but very few people do.
Okay, that was the last question that we have at this point.
Great. Well, thank you everybody for attending this session, and hopefully you'll have the time to attend future wish sessions, because Ree always puts on really good ones.
And I promise that I will have this one processed and uploaded to YouTube this afternoon. So I will tweet the link, and we'll try to make sure that it goes out as part of the follow-up email that you get for attending. So thank you very, very much, everybody, for attending today. Ginger, thank you very much for presenting to us. We'll try to schedule something with you again in 2019 if you're interested.
I'm definitely interested. Thank you so much, Ree.
And some of you guys we will see next week. So thanks a lot.